Great. So like A, does it have a predecessor? Really? A doesn't have a predecessor. A, no predecessor at all. How about boy? Boy as well doesn't have a predecessor. C comes after A. C comes after A. D comes after BC. D comes after BC. And then we have E, which comes after dog. E comes after dog. And then we have got F, which comes after dog as well. And then we've got G, which comes after EF. After EF. So then they want us to use these precedence relationships to draw a project network. What I don't know is whether, is there any student, ladies and gentlemen, from this information that is provided here? Is there any student who can try drawing a network for us? Is there any student who can draw this network for us, ladies and gentlemen? Any student who feels that this, for sure, I can pull a network diagram from this? Brian says yes. Who else can say yes there? Many of them, they are saying yes, yes. Chebi also yes. Thank you. So, ladies and gentlemen, what we have here is A and B do not have predecessors. Hazina, your beginning activities. A and B are the beginning what year? Activities, because they do not have a predecessor. Remember that to precede is to come earlier. Like now, ladies and gentlemen, to precede, like now, ladies and gentlemen, Uhuru Kenyatta was preceded by who? You know, there is what we call succeed and precede. To pre means come earlier, earlier. To precede is to come earlier, So in this case here, Kibaki, yes. So Kibaki came, and then after Kibaki, now we had Uhuru. So like here we are told that A and B do not have predecessors at all. So they must commence from the project start node. So we have, this is activity A, this is activity B. So from there, come and give them their project completion nodes like that. Then we have C. C now comes after what? Somebody. C. You can see that C is preceded by A. That A must come first. That A must be completed before we have C. C, basically when we talk of predecessor, when A precedes C, it means that C comes after A. So after A here, will come and pull C. Will come and pull C there. And then now we have dog. Dog comes after B and C. So I would want B and C to end together. I would want B and C to end together. And because they are starting from different points, there is no problem. You can come and drop C there, so that now this node signifies the end of B and C. And after the two have ended together, now you can come and pull. Now you can come and pull an activity there. Activity called dog, which comes after B and C. This is dog, which comes after B and C. Now I need to come and comfortably rub the old C. We rub the old C like that. That's dog, which is dependent on two activities ending jointly for dog to start. After dog, we have E, which comes after dog alone. So E comes after dog alone. So we have E coming after dog alone. After E, we have F. F also comes after dog alone. So F comes after dog alone. So we have our F there. We have our F there. From there, ladies and gentlemen, we have a G. G, we are told, comes after E and F. G comes after E and F. Can somebody advise me? What do you think am I going to do to have E and F ending jointly? I would want to join E and F because they are required to end jointly for us to be able to have the last activity called G. So the question is, what do you think will I do to be able to have E and F ending together? E and F ending together. I can see James saying, use a dummy, use a dummy, use a dummy. How about the other students? What are they able to tell us, ladies and gentlemen, about E and F ending together? That E and F must be joined for us to have activity G. For us to have activity G, E and F must be tied together, must be joined. must be joined, must be tied together. Connect both to G. Gertrude, connect both to G. I don't know what Gertrude, I don't know what Gertrude really wants me to do here. I would really have wished if all of us knew how to mute our mics. I would have wished to give Gertrude a chance to tell me, how do I connect both to G? So do I come and, for example, introduce a node there? And then I have, for example, E going there. F, no. So will you call this G? Because we don't call these events, we don't call them any letter. No. That one we refuse. Our aim, ladies and gentlemen, is to ensure that E and F are going to end together. And as James is telling us, I wouldn't have had any problem when E and F, if E and F were to end together, I wouldn't have had any problem. If E and F were to end together directly there. But now there is an issue that the two again shared a common start. The two, E and F have shared the same common start, same stroke common start, the same starting point. So if I have them again ending together, then I'll have introduced what we call parallelism. I'll have introduced what we call parallelism. We don't want parallel activities, ladies and gentlemen. Parallel activities can never be entertained. In network analysis, the moment I know how to handle parallel activities, then I will have understood the entire network. So, ladies and gentlemen, here then the only thing that I need to do is to come and make F a little bit longer and then ask myself, if these people, if these activities here share the same start and they can't share now the same end directly, then they can only share the same end in a fake way, in a fake manner. The fake manner is what we are seeing students calling what here a dummy, which is a dotted line. A dummy, like that. So now, ladies and gentlemen, then we have this node, which now signifies what here, somebody? The ending of both E and F. And once both have ended there, now I can come and pull my last activity known as what here, somebody? Known as G. Remember that a dummy is a non-existent activity, which does not consume any resources. So besides dummy, I must always put what there, somebody? 0, like that. 0. So whenever I realize that two activities are sharing the same start, and I would want the two to end together, then the only way out, ladies and gentlemen, is to introduce what here, somebody? Is to introduce a dummy. I know these are things that we shall be doing severally, and I'm so sure that why can't you extend E instead of F? One and the same. You can also decide to extend E and then you pull the dummy up. Yeah, that's still okay. You'll still end up getting the same what here? Answers. Same answers. So, and that is the end of that. Now, the only thing that I need you guys to do is to come and show the arrows movement of the network diagram. It's forward moving, like that. Yes, and then now look at this very interesting thing. Look at this very interesting thing. They want us, ladies and gentlemen, after you have done whatever we have done, they want us to give them the expected duration of the project. So then I would want to go and get the project, or rather the activity A duration. How long will activity A take? Ladies and gentlemen, activity A is a funny one. Activity A, instead of this examiner giving me, ladies and gentlemen, instead of this examiner telling me the exact duration of A, what they've done is to give me 3-time estimates. They have told me if it's activity A will either take 3, 4, 5 with their corresponding probabilities here. We have 0.25, 0.50, we have 0.25. So then in this case, you can't tell me that A will take 4. You can't tell me that A will take 5. In this particular case, I'm going to work with an expected value. I'm going to work with an average. So what I would want to hear from you, ladies and gentlemen, tonight, what do you think will I do to be able to get this average? Remember, it's either take 3, 4, or 5. What do you think will I do to be able to get this average? What will I do? So you get some students in this case here giving you funny figures. They'll tell you, Mwalimu, to get an average there, take 3 plus 4 plus 5 divided by 3. I would have gladly done that if probabilities were absent. Another student who is very bright will come and tell you that expected time is A plus 4 M plus B divided by 6. Ladies and gentlemen, I would have done that. You can see even one is giving me that. I would have done that if probabilities, thank you, Brian, but that's not the way here. Here, there is nothing like optimistic. There is nothing like pessimistic, but that, of course, tells me that Brian, for sure, Brian watched my videos. Ladies and gentlemen, remember that in light of probabilistic information, whenever we have probabilistic information, then to get expected time, what you need to do is to come and take X values times their corresponding probabilities, and then you add them. Just like you used to do in financial management. You take a value times its corresponding probability, right? A value times its corresponding probability. So then what do we have, ladies and gentlemen? For A, I have 3 times 0.25 or means I add. So 4 times 0.5 or 5 times 0.25. Could you kindly give me the expected figure for A? Give me the expected figure for A. So James tells me that A will take us exactly 4 weeks. Expected time for A is 4. How about expected time for B? I would want somebody in this case here to continue with this nice work and give us the expected time of B. Expected time of B. Expected time of B. Expected time of B. What do we have there? Expected time of B. Expected time of B. Fatima has already given me a figure. No, don't round off. Don't round off really to a whole number. If you get it 5.9, it's 5.9. How about the other students? Let's get stuck to our tradition of aggressiveness. The tradition of, ladies and gentlemen, trying our best to do the multiplications. We are doing the multiplications ourselves. Trying our best to give whatever figures. Omar Abdi, thank you very much for diving in. It doesn't matter whether you've been with us from the word go or not. That's not really important. For now, this is what we are tackling. We are getting expected value of B. So for B, ladies and gentlemen, for B, I can see the 3-time estimates. So for B, what will I do for B? I can see the 3-time estimates. So for B, ladies and gentlemen, for B, I'll take 4 times 0.15 plus 5 times 0.3 plus 6 times 0.2 plus 7 times 0.2 plus 8 times 0.15. Because I can see their 3-time estimates. Great. So they're telling me B is 5.9. They're telling me B is 5.9. How about cow? How about C? Thank you very much, Walter. How about cow? How about cow? How about C? So long as you've got that question and you're able to see the values there with the probabilities, what you do, you multiply and then you add them up. You keep on adding them up. So C, is there anybody who has an answer for C? Is there anybody who has an answer for C? For C, Fatima says 4.6. Is there anyone else who is able to support that 4.6? Omar says 2.9. So there must be somebody between the two is wrong. There must be somebody between the two is wrong. So we need in this case here to get. Fatima, just check your answer. Most of them are saying for cow, it is 2.9. Fatima, please check your answer. Most of them are saying that for C is 2.9. Most of them, even Joseph has confirmed. For C, we have 2.9. In Phoenix Mat 5, I've not heard your voice. Jonathan, I have not heard your voice. Fatima has confirmed the 2.9. Becky, I've not heard your voice. Adega, thank you very much, 2.9. Please, this is a football match that everybody must play. Thank you very much, Kiama, 2.9. Now let's go to D. Let's go to D. D, what do we have there? Somebody for D. For D, what do we have there for D? D, Fatima says 4.2. That's only one student who has been, Omar also has confirmed the same. Average 4.2. Thank you very much, Joseph. Thank you very much, Becky. Kiama, thank you very much. Great. Could there be anybody who has an answer for E? Could there be anybody who has an answer for E? An answer for E? An answer for E? An answer for E? Could there be anybody who has an answer for E? An answer for E? So E, I'm being told, is 4.8. E is 4.8. How about, Sharon says 2.7. I don't know. Paul confirms 4.8. Sharon, please check your answer for E. Sharon, please check your answer for E. Thank you very much. Thank you, Joseph. Thank you, Joseph. The students, Jonathan, thank you very much for diving in. Thank you, Walter. 4.8, 4.8. John M, thank you very much. Thank you very much, Redemptor. 4.8, thank you. How about F? F, is there anybody who is able to give me the value for F now? Average value for F. Fatma says 6.6. Omar confirms the 6.6. Paul gives me 6.6. These students are supposed to be giving me these answers, really. They're supposed to be very many. They're supposed to be very many. Juhudi, I've not had you giving me any answer. Boris, I haven't heard from you. Moses GW, I haven't heard from you. So 6.6. And then lastly, my friends, now we have the G. So G will be equal to who? G. Paul tells me 2.5. Joseph tells me 2.5. Joseph tells me 2.5. G, 2.5. Redemptor also has confirmed the same. So could you kindly do me a favor, my greatest students? Could you kindly do me a favor? The favor that now I would want you to do for me, I would want you to come and subdivide this, and then now using the expected time, I would want to see whether their students will be able to use the expected times very well, use the earliest event times, forward pass, to give me these figures. Start from 0 as usual there, and then move along. Please play along, play along. Please play along. Let's see how far you will go. Let's see how far you will go. Let's see how far you will go. So you're feeling inside there. I'm giving you 3 minutes. We try all of us to do some fill up, and then we compare notes. Great, 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 great. Where are we? So using the forward pass, is there anybody who is able to give us an answer? According to Chebi, we have 20.2. According to Chebi, we have 20.2. So I would want to confirm that figure from somebody else. I would want to confirm that figure from somebody else. Fatima has been able to confirm that figure. Fatima has been able to confirm that figure. And I would want us to do it together. I would want us to do this together. I would want us to do this together. So, then, gentlemen, remember forward pass is all about what you are adding. You're adding. So like 0 plus 4. This gives me exactly 4. Right? But when you come to this node, you have to be very careful. Why? Because there are two roads leading to this. We have road C. Road C will give me a cumulative of 6.9, comma. Then we have road B. Road B will be 0 plus 5.9. Remember, forward pass, you keep on adding. So now here we are comparing between two animals, 6.9 and 5.9. Remember, when we are moving forward, we always have the higher prevailing, the highest prevailing. So between the two, it is 6.9 that will prevail here. Between the two, it is 6.9 that will prevail there. 6.9. So we always work with the higher. In forward pass, we always work with which one here? Somebody? The higher. We always work with the higher. So this one here should be 6.2, 6.9. Ladies and gentlemen, here there is no comparison at all because there is only one arrow. So what is 6.9 plus 4.2? That must be 11 point what here, somebody? 11.1 if I'm not wrong. So 11.1 if I'm not wrong. So 11.1 plus 4.8. 11.1 plus 4.8, that gives me 15.9. No comparison at all. But when I come to this, there is comparing. There is comparison to be done. There is a dummy arrow getting into this. The dummy arrow will give me 15.9. And then now there is the F arrow. F arrow will be giving me 17 point what here, somebody? 17.7. So between the two, which one should prevail? The higher. So the higher is the one that I'll put here. 17.2, 17.7 like that. 17.7 is what I'll put there. So this is supposed to be 17.2. This is supposed to be 17.2, 17.7. And then, of course, there is nothing like comparison here. So here I'm supposed to come and take 17.7 plus 2.5, which gave you, gentlemen, ladies and gentlemen, 20.2. And then I will come and put 20.2 here at the very end. Put 20.2 at the very end, and then now you subtract backwards. Now it's backward press. You move right away from there up to the end here, where we shall be able to get a 0. 20.2. Now you keep on subtracting backwards until we get a 0. 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 So remember, we are moving backwards until we get what here? Until we get a 0. Until we get a 0. Moving back as you subtract. The bottom ones, we keep on moving back as we subtract. We keep on moving back as we subtract. Black. Okay, so please subtract back 20.2 minus 2.5. What are we getting? We'll get 17.7. Right? And then we move here 17.7 and subtracting 0. Backward pass. So 17.7 minus 0, that gives us still 17.7. Great. Ladies and gentlemen, look at this. This one here is a funny one. Why? Because there are two arrows moving backwards into it. Two of them. I will not panic at all. I'll just calculate their two-time differences. So I'll have here 17.7 minus 4.8. Somebody have to give me this figure. What is 17.7 minus 4.8? Somebody give me this figure. Somebody using your calculator. What is 17.7 minus 4.8? 12.9. Thank you very much. So I'll be comparing 12.9. I'll be comparing 12.9 vis-a-vis 17.7 minus 6.6. 17.7 minus 6.6 gives me 11 point what here? 11.1. Na nikakwambia kama ni backward pass, for those of us who love football, we know that backward pass ni mpira mdogo mdogo. Ukipiga farthest utajifunga. Backward pass ukirudishia goalkeeper mpira, unapiga mpira mdogo mdogo. So backward pass you always work with the smaller. So the smaller here which will prevail is 11.1. The smaller which will prevail there is 11.1. Is 11.1. So from there we have 11.1 minus 4.2. 11.1 minus 4.2 will give us what figure? 11.1 minus 4.2 will give us what figure? 6.9. Thank you very much. So 6.9. Thank you very much. Now from there, ladies and gentlemen, we are almost there. How about here? Here it's only one arrow going backward. So 6.9 minus 2.9, that gives me 4. And then lastly, now we have this one, which is 4 minus 4, 0. Of course, 0 will prevail there. So now, having, ladies and gentlemen, gotten that, I would want to see whether we have some students who will be able to tell us which activities are critical, which activities are critical, which activities are critical, which activities are not critical. So I would want us to establish the critical path activities. Is there somebody? Yeah, I can see what Walter is telling me. A, C, D, F, G. I can see what Walter is telling me. Walter is telling me that Mwalimu mark A. When you ask him why A, because of the similarity. So 0, 0, we have 4, 4. Similarity. And then when you take the head minus the tail, the head is 4, the tail is 0. So 4 minus 0, we are getting exactly 4. And this exactly 4 that we are getting is exactly identical to A's duration. So the difference is 4, the head and the tail difference is 4, and the duration of A is 4. So they are coinciding. So it means that A must be what here? Must be critical. Confirmed. Look at boy. Boy, I agree that there is a match between the tail. There is a match between the head. But when I take the difference between the head and the tail, that difference gives me 6.9. And then, ladies and gentlemen, we have the duration here. The duration of boy is 5.9. They are different. So meaning that there is no way boy can ever be critical. Critical, ladies and gentlemen, we must always see a situation where the tail timings are the same. Then we have the head timings also coinciding. And then when you take the head minus the tail, this 6.9 minus 4, it gives me 2.9. There is a coincidence that that difference is exactly equal to the duration of C. So C automatically is critical. And of course, I'll be able to bear witness with you, ladies and gentlemen, that T is also critical. So F will be critical, G will be critical. So ladies and gentlemen, if that is the case, I'll come and tell my examiner that the CPA, I'll come and tell my examiner that the CPA equals who? I will come and tell the examiner that the CPA, critical path activities are A, C, D, E, F, and then G. And then project duration is 20.2 weeks. Project duration is 20.2 weeks. Fatma says E is supposed to, no, E is not supposed to be there. Thank you. It is supposed to move like A, C, D, F, G. How could I not? E is not critical. Thank you very much. E is not critical at all. 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 So, ladies and gentlemen, having done that very nicely, I would want you to do me one favor. I would want you to do me one favor, only one favor, only one favor. So we have got two paths. Are they two or more actually? To shall pick the critical. This is the critical. What about the other paths? What about the other paths? The other paths we have here, A, C, D, which you can make as a move from beginning to the end. I can go A, it's a road I'm following with my vehicle, D, F, G. A, C, D, F. No. That is the one that is here. There must be another one, which I can move with my vehicle to the end. A, C, D, E, dummy, G. A, C, D, E, other parts. A, C, D, E, dummy. And then we have what here, somebody? G. Other paths. We also have another path which I can move very comfortably with my vehicle till I go to the end. I have B. I have B. I have dog. I have E. I have dummy. And then I have got G. And then I've got B, dummy, B, dummy, B, dummy. And then we have got F, vis-a-vis what, somebody there, G. So I'll tell you later on where we are picking, why we are picking these other parts. For now, just mention them. Just mention them like that. Just mention them. Just mention them. Just mention them like that. Just mention them like that. So what I would want us to agree from the word go is that the critical path activities are A, C, D, F, G, and the project duration is 20.2. The project duration is 20.2. Those are the two things that I would want us to agree. Once you agree on that, then myself, I'm very comfortable with proceeding with the question. And I believe that when I will call upon you to give me the other parts, you'll be able to read for me these ones. Otherwise, why did I start this thing with you? I started this thing with you basically to take you through what we call simulation analysis. For the students who have just joined us, there is a topic we did, which we called the simulation, simulation analysis, where we said that simulation is all about what is somebody imitating reality. To simulate is to imitate reality. And the most important thing that you're supposed to know about simulation is this. How do we assign random number ranges? How do we assign random number ranges? Tukasema random number ranges, that if you've got one decimal place, then you've got one digit. One decimal place, how many digits? One digit. Well, this is strange. We are many of us who are new. And I like it that way because at the end of the day, the new students, all of them will end up understanding this better. So when we say one decimal place, one digit, it means that our ranges will be running from 0 to 9. One decimal place, one digit will be 0 to 9. When I talk of two decimal places, we have got two digits. They rhyme like that. So two digits, number mbili, itakuwa 00 all the way to what here, somebody? To 99. 00 all the way to 99. 00 all the way to 99. What do you mean with this? Listen, my friends, if you want to start a business today, and perhaps you know that the price you are going to charge could either be 20 or 25, and then they have given you probabilities of 0.3 and 0.7. How will you be able to assign random number ranges to this probabilistic variable? How will you be able to assign random number ranges to this probabilistic variable? So could you kindly write, first of all, up to here? Very important. First of all, we leave out, we put it away, we put the network away, we try to understand this. So please write this example, very important example, where they have given me the price and then they have given me probabilities. So the question is, how do I assign the random number ranges here? How do I assign the random number ranges here? The first thing that I will do is to come and ascertain what we call the cumulative probability. So cumulative probabilities, we are basically adding downwards. So could you kindly help me add downwards here, somebody? So adding downward, this will give me 0.3, and then you come and add this here. So this gives me 1.0. We must be consistent with decimal places. We must be very consistent with the decimal places. Ladies and gentlemen, after that, I would want you to come and give me the random number ranges. So random number ranges, what do we have here? Listen here, listen here. Ladies and gentlemen, for random number ranges, we shall always be sensitive to the decimal places. So we see here we have got a decimal place 1 only, 1 decimal place. Then our ranges will be made up of only 1 digit number moja, which will be 0 to 9. But remember, it will be 0 here to 9 last. But remember, we have got this range. So the first range, how do we get the first range? At first, this may look a little bit complicated, but it's a very simple thing. So ladies and gentlemen, listen here. To get the range here, to get the upper limit for my range, because range must have lower and upper. To get the upper limit for my range, what I'll do is to come and read this number as if it's a whole number. So we're reading this as if it's 3. So we read it as if it's a whole number, and then we deduct 1. We deduct 1. So we read this as if it's a whole number, which is 3, deduct 1 to get the upper limit. So the upper limit here will be what? Somebody there will be 2. Now listen, my friends. How about the next range? The next range will start from the next number, which is what here? 3. And it will go all the way to the upper limit. I'll have to read this number as if it's a whole number, which is 10. So what is 10 minus 1? You read 10 minus 1. That gives me 0 to what here? Somebody? 0 to 9. This is example 1, which I would want to assume that nobody has understood it. But even if you have understood it, you understood it by mistake. So that I can now again do another example. So example 2, ladies and gentlemen, what do we have here for example 2? So example 2, again, I would want to get stuck on my price example. So the price, which could either be 25 or 30, and then they have given me probabilities. They have given me 0.20, 0.80. Could you kindly just try, in this case here, getting random number ranges out of this? Just try. I'll repeat severally. I will repeat severally. Brian, not understood. No problem. I'll repeat again. Just try. Just try, first of all, with whatever knowledge you have seen. Even if it's cumulative probabilities, just write cumulative probabilities there. So that when I repeat once, all of us will be able to understand this once and for all. Thank you very much, Brian, for coming out boldly like that. Those are the kind of students I like. Already Gertrude has an answer. Thank you very much, Sharon. Look at these students. What are they telling me? Brian, look at this. Brian, look at this. It's a very straightforward thing. It's a very straightforward thing. What they're telling me is that Mwalimu, first of all, let's get cumulative probability. Let's get cumulative probability. So we have here cumulative, it will be 0.20. We are accumulating, we are adding. So when we are adding, this will be 1.00. Remember, we must be very sensitive to the decimal what here, to the decimal places. After that, now I'll be able to generate my random number ranges very comfortably. Now, Brian, look at this. How many decimal places? 2. Don't tell me that this 0 is insignificant. No. For us, we know that the level of accuracy is 2 decimal places. So we have here 00 all the way to 20 minus 1. The upper limit here is 20 minus 1, which gives me 19. And then we have the next class, beginning from the next number, which is 20. 20 all the way to 100 minus 1, which gives me what here, somebody? 99. So Brian, I'm on your neck. I would want to know whether you have understood now. Or any other student, I would want to know whether you guys have been able to follow what I've done to get the random number ranges. One last, no problem. Thank you very much. The last one. So the last one, what if, for instance, you're given a probabilistic variable, which is what here? X almost there, yes. Which is, for example, X, whose value could either be 3, 8, or 11. With what probabilities? We have 0.3, 0.2, and then 0.5. So this is example number 3. So for example number 3, could you kindly give me the random number ranges, ladies and gentlemen, kindly? Random number ranges, how will they look like? Kindly. Okay, so thank you very much. So this is where we are. The first thing that I need to do is to come and give them the cumulative what here? Probabilities. So cumulative probabilities, what do we have here? We have 0.3, we have 0.5, and then we have 1.0. From there, ladies and gentlemen, now I need to come and provide the random number what here? Ranges. So the random number ranges, what do we have at the end of the day? Ladies and gentlemen, of course, this is a one-digit thing because of one decimal place. So it will be 0 all the way to 3 minus 1, which is 2. Next number after 2 in the number line is 3, all the way to 5 minus 1, which gives me 4. Then thereafter, we have got 5 all the way to 10. 10 minus 1, that gives me 9, like that. That gives me 9 like that. So now, ladies and gentlemen, I would want you to do me a favor. Let's get now back to our network problem. So our network problem, Roman 3, they want me to simulate. Our network problem, Roman 3, they want me to carry out simulation analysis. And for me to be able to carry out this simulation analysis, what I expect of you, great students of mine, is number 1, to ascertain the random number ranges for each activity. We ascertain the random number ranges for each activity. And I'm not going to show you how. So we start with activity A. So activity A, I would want us to start with activity A. So for each activity, activity A, so activity A, what do we have? We start with activity A. So activity A durations, we could either have what here? Somebody could either have 3, 4, or 5. And then they have given me the probabilities. Probabilities are 0.25, 0.50, then we have 0.25. Then we have got activity B, which could either be 4, 5, 6, 7, 8, with the following probabilities. Probabilities here are 0.15, 0.30, 0.20, 0.20, 0.15, and then we have activity C. Activity C, what do we have, ladies and gentlemen? Activity C could either take 1, 3, or 5 with the following probabilities. So we have here 0.20, 0.65, we have 0.15, then we have got D. D, which could either take 4 or 5 days. 4 or 5 days. D could either take 4 or 5 days. 4 or 5 days with a 0.20. No. D is bigger. Yeah, 4 or 5. 0.8, 0, 0.20. And then, ladies and gentlemen, we have got activity E. So E could either take 3, 4, 5, 6 with the following probabilities. So probabilities we have 0.15, 0.25, 0.25. Then we have 0.35. And then we have got F. F, which is 5 or 7 with the following probabilities. We have 0.20, 0.80, and then we have got G. G has got 2 of them, 2 or 3, with 0.5, 0.50. So those ones will always be given by the examiner. So what you need to do very fast while running, come and give us the cumulatives. Give us the cumulative probabilities, and then later on you create a column for random number ranges. That is your work. Perhaps I could just guide you to do the first one. So the first one cumulative will be 0.25, 0.75, 1.00. That ends there. And then now random number range. Is there anybody who is able to give me the random number ranges for the first one? Anybody who is able to give us the random number ranges for the first one? For the first one, random number ranges, I'm losing out. I can see some of them are dropping out. So wananiambia kwanza ati ni 00 to 25 minus 1, which gives me 24. Next one is 25 all the way to 74. The next one is 75 all the way to 99. So now could you kindly do that way for the rest? For the rest, try that way for all of them. When you finish, tell me I have finished. Good, good. I can see what James Areba has. Good. Please, when you finish, let me know. Let me know when you finish. So please, when you finish, let me know you finished. Anybody done? Okay. Done. Thank you very much. Thank you very much. Let's compare notes and see. Let's compare notes and see. I told you by the end of the class, each one of us here would be an expert. So cumulative. Thank you. Thank you very much. So cumulative, then cumulative here. I'll come and do the cumulative probabilities. This will be 0.15, 0.45, 0.65, 0.85, 1.00. So random number ranges, then these will be 00 to 14. This will be 15 to 44. This will be 45 to 64. This will be 65 to 84. This will be 85 to 199, 100 minus 1. So come here very fast and do the same. Give us the cumulative probability 0.20, 0.85, 1.00. So random number ranges. We have 00 to 19, 20 to 84. Then we have got 85 to 99. Here we have cumulative probabilities. So we have 0.80, 1.00, random number ranges. We have 00 to 879, 80 to 99. Thank you. So go to the next one. So for my case, I've already captured what is enough. So I want to believe you have finished already working on the next one. So ladies and gentlemen, now we go to where the rubber meets the road. Where the rubber meets the road. What do we have here? Where the rubber meets the road, I would want us, ladies and gentlemen, to come and really do what we call a simulation worksheet. So mention there, simulation worksheet. So simulation worksheet. Mention there, simulation worksheet. Thank you. So simulation worksheet, simulation worksheet. So simulation worksheet. So we have here our simulation worksheet. So in this simulation worksheet, remember the first thing you need to do is to come and give us the run number. So give us the run number. And this examiner, yes, this examiner asked us to do only 2 runs. To do only 2 runs. And what are we trying to predict, ladies and gentlemen? In our case, our dilemma is all about the duration. How long will we take? Adjust the camera for the simulation worksheet. For the simulation, perhaps this is what they are not able to see, the simulation worksheet. The title here, Fatima, is simulation worksheet. Simulation worksheet. Because I don't want to make my number smaller. What you are suggesting is that I make my number smaller. If I adjust it a little bit, those numbers will have to become smaller. So what they would want me to estimate, ladies and gentlemen, is the durations of the activities. So we have the duration of A, duration of B, duration of C, duration of D, duration of E. Then we have duration of F. So they would want me to estimate the durations of the activities. The durations of the activities. That is what they want me to do, ladies and gentlemen. Estimate the durations of what here? The activities. But how do we estimate the duration of the activities? Using the random numbers that the examiner must always give you. Use the random numbers which the examiner must always give you to predict each duration there. To predict each duration there. To predict each duration there. Each duration has to be predicted using Rn. Rn, if you're taking notes, Rn means what here? Random numbers. Rn means random numbers. Rn means random numbers. Rn means random numbers. And unfortunately, this examiner, for whatever reason, he forgot to give us He never gave us the random numbers. So what a good student will do in that kind of a scenario is not to cry. You'll simply come and say assumed random numbers. Assumed random numbers. So come and assume them. So we have, for example, 80, 90, 83, 91, maybe 95, 72, 69, 83, 01, 94. So we have here, for example, 32, 43, 41, 82, 95, 91. We have, for example, 23, 52, 55, 61. So this examiner never gave us random numbers. He never gave us random numbers. We shall assume ours. He forgot to give us random numbers. And of course, whenever that happens, ladies and gentlemen, we normally end up giving free marks at CASNEP. So, but don't be there praying for errors. Don't be there praying for errors. No, no, no. Now, ladies and gentlemen, remember that our digits here are how many? They are 2, 2, 2, 2. So even if the examiner gives you 4 of them, you are coming here to subdivide into 2, 2. So like you'll come and pick the first one here is 80. The second one here is 90. First of all, you fill random numbers throughout. 83, 91. So we have here and random number 83, 91, and random number 95, 72. 95, 72. And then we go to run number 2. Run number 2, we have 32. We have 43 here. We have 41 here. We have 82 there. We have 95. 95, 91. Ngoja. Sikumaliza zote we. Ngoja. Sikumaliza zote oye. Mimi nimeenda kwa line 2 bila kumaliza zote. Ili ishia 72. After 72 we have 69, 83. Unamaliza zote 69, 83. 0194. 0194. Alafu tunaanza 34, 43. 32, 43. Kwisha namna hiyo sasa. Kwisha namna hiyo sasa. You even left G. I've left so many things. E, F, G. Mwisho naambiwa kuna G. Inafaa ikuwe, lakini sasa hiyo ni yenu. Hiyo ni yenu, hiyo ni yenu, hiyo ni yenu. Hiyo ni yenu. Hiyo ni yenu. Weka moja hapa random number na G. Weka random number na G oye. Kwa hivyo ukiweka random number na G, hizi namba zinabadilika. Pata potea, hapana chukia mimi. Pata potea. Hiyo ni part of learning. Weka random number na G pale. So after 72, after 95, 72, I can see 69. I can see 69. And then we have 83. After 83, what do we have? 01. And then now 94. 94, 32, 43. 32, 43, 41, 82. Now atarudia tena. Hata ukisema tumekosea, tena hakuna kurudia. Now do me a favor, ladies and gentlemen. Random number 80 corresponds to what duration of A? Random number 80. Random number 80, random number 80. 80 falls here. Akia wafuati. 80 is in between here. It corresponds to 5 days. So 80 corresponds to 5 days for A. How about 90 for B? Let me now keep quiet a little bit. 90 for boy. 90 for boy. Can somebody talk to me tonight? 90 for boy. 90 for boy. Fatima says 8. Omar says 5. Esther says 8. Paul says 5. Sorry. Remember, it's 90 for boy. So 90 for boy. Where is 90? It is here. The last one. So it has to be 8. It has to be 8. Thank you very much. How about 83 for cow? 83 for cow. 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 Fatima says for cow, 83 is here. Great. 3. How about 91 for dog? 91 for dog. 91 for dog. 91 for dog. Unasema ni 5. Great. Now E sina, E mimi sina, lakini uko nayo E mahali. 95 for E. 95 for E. 95 for E. Inakuja ngapi sample 95 for E? Wanasema 6 ama 8? 6. 6, thank you very much. How about 72 for F? 72 for F. 72 for F. Paul anasema 7. 72 for F. Paul anasema 7. Ya mwisho katika round number 1 ni 69 for G. 69 for G. 69 for G. 69 for G. Paul ameanza na 3. Fatima na 3. Esther na 3. So inafaa kuwa 3. Haya, tuendelee namna hiyo. 83 for A. Tuanze mwanzo tena huko juu. 83 for A, mimi nimeshaona answer yake. 83 for A. 83 for A wanasema ni 5. 83 for A. 83 for A na 4 hapa, unaona? 5. Thank you very much. How about boy? 01. 01 for boy. Thank you very much. I can see everybody really, despite things being tough, everybody is playing ball. So in this case, ladies and gentlemen, 01 for boy wanasema ni 4. 01 for boy wanasema ni 4. 4. Thank you very much. How about 94 for cow? 94 for cow, J. 94 for cow. 94 for cow. Wanasema ni 5. Thank you very much. 32 for dog. 32 for dog. We're trying to estimate. 32 for dog wanasema ni 4. How about 43 for egg? 43 for egg. 43 for egg. 43 for egg wanasema ni 5. How about, ladies and gentlemen, 41 for F? 41 for F. 41 for F wanasema ni 7. 41 for F wanasema ni, lastly, tuko na 82 for G. 82 for G. 82 for G wanasema ni 3. 82 for G ni 3. Ukishafika hapo, unakuja unapatia the total durations. Givers the total duration. So kuja kama ni duration of A ili 10. Duration of B 12. Duration of C 8. Duration of dog 9. Duration of E 11. Duration of F 14. Duration of G 6. 6 like that. Alafu, of course, at the end of the day, you guys wanted the averages. At the end of the day, you want the averages. At the end of the day, you want the averages. You want the average duration. So come and give me here another row for average duration. So average duration, come and take this, you divide by 2 runs. All this you divide by 2. All this you divide by 2. All of them you divide by 2. Na mimi nazijua sana hizi. Average duration ya kwanza woye itakuwa ni 5. Ya pili average itakuwa ni 6. Ya tatu woye hapo itakuwa ni 4. Hii itakuwa ni 4.5. Hii itakuwa ni 5.5. Hii itakuwa ni 7. And then lastly, we have 3. Like that. 3. Like that. 3. So those are the average duration. So as we finish, please come and remind me the paths from our network diagram. Start with the CPA. The critical path ilikuwa ni gani? Start with the CPA. Start with the CPA. Arakaraka woye. Start with the CPA. What do we have? What do we have with the CPA? Remember our paths. I told you to mark them somewhere. CPA umesema ni A, C, D, F, G. A, C, D, F, G. And then we have now the other parts. Is there anybody who is able to remind mwalimu here the other parts? Very first. The other parts, very first. The other parts, very first. Patapotea. The other, utashika sana mambo mimi na wasiwasi. Utashika sana. The other parts, ladies and gentlemen, the other parts. What do we have for the other parts? For the other BDE dummy. BDE dummy G. Thank you very much, Redemptor. How about path number 3? Someone else to pick path number 3. Path number 3, what do we have there? Somebody? Path number 3, ACDE dummy G. A, C, D, E, dummy, G. From there, now we have the last one, which is F, B, D, F, G. B, D, F, G. Great. B, D, F, G. B, D, F, G. B, D, F, G. Now, ladies and gentlemen, listen here. So once you have these paths and you have the average durations, combine them to get the total path duration. Nisikize, kama A, si umesema A ni 5, na umesema C ni ngapi, umesema C ni ngapi, si umesema C ni 4, umesema dog ni ngapi, si umesema dog ni 4.5. F umesema F ni ngapi, umesema F ni average yake ni 7, na G ya mwisho ukasema ni ngapi, somebody ni 3. So could you kindly give me the total durations? If I follow this path A, C, D, F, G, given the simulated durations, how long will that path take me? How long will that journey take me? It will take me 23.5 days. 25 days. Aki wengi wajafuata. Ebu angalia B, D, E, G. Angalia B. B takes me how long? B, I know B takes me 6. B takes me 6. D takes me what? D takes me 4.5. E takes me what? E takes me 5.5. Then, of course, is 0. And then we have G. G lastly is 3. Can somebody give me the duration of the second path? Somebody give me the duration of the second path. Nikuambia story mzuri. The duration of the second path. Nikuambia story mzuri. Duration of the second path. So Omar says 19. So mimi nafaa ninyamaze, ningoje wengine mnipatie number 3 na number 4. Sasa inafaa mimi ninyamaze kabisa, ningoje number 3 na number 4 kutoka kwenu tena. Mimi nafaa ninyamaze kabisa, mnipatie number 3 na number 4. Pata potea. So number 3, wanaambia ni 20.5. Hiyo ni gani hiyo sasa? 20.5 number path 4, 20.5. Path 4 is 20.5. How about path 3? Path 3J, 22 anasema 22. So ladies and gentlemen, which one is the longest path? It is still path number, thank you. It is still path number 1. So path number 1 is the longest, which means that it is still our critical path. So meaning that even after simulations, path number 1 will remain the CPA, but now after simulation, the simulated project duration will be 23.5. The simulated project duration will be 23 what here, somebody? 23.5. Will be 23.5. At times we'll get other paths becoming bigger than this. So the critical path can change. That's why you must do a path analysis. So, ladies and gentlemen, we've come to the end of this particular question. The examiner wanted us to simulate the project, and that is what we normally do. And today, as I've been teaching, I've really had that yes, please ask.